Okay, I think we're live. So welcome everyone to this first NTU Psychology Research Seminar of the year. This is a really strange way of doing these. It's different to what we normally do, but hopefully it's going to work smoothly. We've got people kind of working behind the scenes. I say people, that's me and hopefully Darren maybe with tech, so hopefully nothing's going to go wrong. Essentially, the way this is going to work is we'll have Darren Rhodes, who's a lecturer here in the psychology department, introducing our speaker today, Dr. Ben Vincent from Dundee. Ben will then give his presentation, which will take maybe 45 minutes or so. And then we've got space at the end for questions where we'll finish by 5 o'clock. You do have, if you're watching online or in a browser, the Q&A on the right-hand side. So if you've got questions for Ben as he's talking, just post them in the Q&A section on the right-hand side. They won't go through to Ben straight away, but I'll be kind of sifting through them as Ben's talking, and hopefully we'll have a collection of questions for him before the end of the talk, so we can go straight into Q&A. I think that's it for kind of housekeeping. So no one's camera should be on, no one's microphone should be on, because that's not a thing for this kind of event. The Q&A is on the right-hand side, so please do use that if you do have a question. What I'll do now is I'll send Darren Rhodes live, who will introduce our speaker for today. So over to you, Darren.
Hello, everyone. Thank you, Craig. So it feels like a radio show / podcast. So so I'm delighted today to I invited Ben a while back, actually. So I think he was originally supposed to come in sort of March time, but obviously the pandemic hit, so that put pay to that. But Ben, I've started talking to Ben about work and collaborating for a while now. So I've actually been fortunate enough to go up to Dundee, which is beautiful. But obviously we want Ben to be in Nottingham, but unfortunately not possible at the moment. So just quickly, so ends up at the university. Graduated from the University of Sussex in 2000 in neuroscience, and continued there with Roland Badley doing some computational neuroscience stuff. I think 2004-ish, and then he did a postdoc with. You're gonna have to help me with pronunciations here, Ben. I can say Ian Gilchrist, but Tom Truscianco.
Truscianco, yeah.
There you go. At the University of Bristol, and then he's been in Dundee since 2007. I believe he knows quite a few in our department, it seems. But Ben's been super influential for my thinking about Bayesian brain stuff and Bayesian decision theory. But yeah, I hope you enjoy today's seminar. So over to you, Ben.
Okay, so I think I'm live. Thank you very much, Darren, for the invite. It's a shame I can't be there, but whenever things get sorted out, I'll look forward to it. So today I'm going to present some work which started with Megan Veyard's undergraduate dissertation. And she actually recently, just a couple of weeks ago, was announced the European winner in the psychology section of the Global Undergraduate Awards. So this is really cool. She's a great student who collected great data. I added my own kind of Bayesian twist on top. So everything that I present here is a mixture of our work. What I'm going to do first of all is to give a brief primer on discounting. So I'm a discounting nerd and know all about it. Hopefully after the next few slides, you will also be a discounting nerd. Now, this is similar to the marshmallow experiment, which is administered to children. But when we evaluate discounting in adults, we typically do this through a series of choices. So on the screen, I've got some example choices here, which span from a choice between £90 now or £100 in one day, all the way down to, let's say, £10 now or £100 in a day. And what you would do is you would get the participants to make choices for each of these, and different people will choose different things. There is no right or wrong answer, but at a certain point down this series of questions, they will change their mind. They will come to a point where they're maybe indifferent, and then past that point, they would go from preferring immediate rewards to delayed rewards. And so you might repeat these types of questions, let's say exactly the same questions, but now you would take a slice down, not just one day, but you might say, what about £90 now or £100 in 1 week? And so you do exactly the same thing and then repeat this for an even longer delay period. And so people may or may not change their mind. Either way, from the raw data you get from an experiment like this, you will be able to trace out a curve. And so there are lots of different types of curve that you might look at, and these all have theoretical motivations behind them. I'm not going to go into that today. All we need to really know about is that we just have a discounting curve. And so we can basically go from a set of questions, a set of responses, and we can reduce that behavior down to a single variable, which we can capture in like the slope of this curve. As I said, there are different ways of doing this, but the kind of intro method would be you would fit a particular curve and you would say, for this particular person, I can explain their behavior with a certain discount rate. Now, sometimes I will call it discount rate. People always call this K for some reason. It's just what people do. People also call it log K, and there's nothing really special about that other than it's just a transformation that people do in order to make the distribution of discount rates more normally distributed across lots of different participants. And so we can imagine running a discounting task on lots of different people, and some people might be more present focused. So if we look at this curve along the top, that would represent as time goes away, as a reward goes away into the future and becomes more delayed, you discount it, but less and less. And so this person might be described as more future focused. Whereas someone maybe perhaps with a addictive disorder or an addictive disorder might discount future rewards much higher. And so their behavior might be captured by a curve which is much steeper. So broadly speaking, discounting is the tendency to devalue future rewards. So when you're given these pairs of options of something now versus something later, virtually always with rewards, the only way that you might consider a delayed reward is if there's more of it. Now, it will become relevant later, but I should say that lots of different types of things could be discounted. In the example I showed earlier, we were choosing between immediate money versus delayed money, but you can also choose between food now and food later. We've done other measures where you look at weight loss rewards, for example. If people are in a hurry to lose weight, they could decide between a small bit of weight loss now or a large amount of weight loss later on. Before we get into the meat of the study, I thought I would do a blatant self-plug and basically talk about a few of the studies that I've been doing with some really great collaborators in recent years. I only relatively recently switched to study delay discounting, and what I did was I started looking at methodological issues. And so there's one paper that we have which applies a hierarchical Bayesian estimation to delay discounting. So there's code that goes along with this paper. It's unfortunately written in MATLAB, which is what I used to do, but I'm reformed now. I've also written a toolbox paper with Tom, and so if you're interested in collecting discounting type data in a really efficient manner in order to analyze it in a Bayesian way, we've written a toolbox that allows you to run these discounting experiments in a very kind of trial efficient manner. So this is on a bit of a hiatus at the moment, and it's been a preprint for a number of years, but we're hoping to get that out embedded within PsychoPy. We've done some work with Neil Stewart. This is a bit more of a theoretical look at cognitive modeling, where we basically found that cognitive modelers were essentially mixing up their oranges and apples, for example, and without going into the details, this led to some kind of interpretation problems. And so we described how this might be a real issue for discounting studies. Although I've also done some kind of empirical work and a kind of like methodological and kind of empirical work equally. So some work I did a good few years ago now, published in 2019, was with a previous student looking at how hunger, we kind of made students come into the lab either hungry or not hungry, and we measured their delay discounting for food and other things, totally unrelated things. And we worked out that hunger essentially made you much more present focused, not just for food as you would expect, but for other types of rewards as well. And this was really taken up by the media. So that was a bit of a crazy week. And kind of weirdly enough, that student back in 2017 was actually the global winner of the undergraduate awards. So that's pretty cool. Recently, I was involved in some work with kind of quite an interesting way of evaluating discounting, where rather than just choosing between kind of hypothetically delayed rewards, we would actually make people wait. So they're sitting there in front of a computer screen and they can kind of click to have small amounts of money now. But if they opted for a larger amount of money in the future, they had to kind of sit there and twiddle their thumbs while it fell from the sky to catch it in this bag. So that was a really fun study. But today we're going to be talking about a paper that's out in Physiology and Behavior, which focuses on whether delay discounting for any particular person might influence their body mass index. So the motivation for this, why should you look at that? The motivation really is to think about what kind of predictors might there be to account for susceptibility of gaining weight. So a lot is made that, at least in the West, we're in this obesogenic environment. And so some people suffer from obesity, some people do not. But similarly, you will have almost the opposite problem where some people are suffering from underweight as well. This, of course, is a hugely complicated topic, and we're not aiming to kind of explain all of this by any means. But wouldn't it be good, wouldn't it be interesting if we could identify interesting kind of underlying cognitive constructs which are predictive of, let's say, over or underweight? If we could identify such a thing, then that could be potentially useful. We could maybe target how people trade off immediate versus delayed rewards, and that could potentially be useful in a clinical situation. So delay discounting is a compelling candidate. Many papers have been written looking at the link between discounting and body mass index. And the motivation for this, I think the theoretical idea behind it is quite clear, in that we're every day, almost maybe even every hour every day, we are faced with trade-offs between, do we want some food now that might taste really good, but which might kind of interrupt long-term weight management goals, for example. So I like to really clearly set out the hypotheses that we came up with. And the first one here on the left is a really simple hypothesis. Is there a correlation between delay discounting and body mass index? This is the hypothesis that has basically been examined in many studies. So we can maybe contribute to that existing pool, and we're going to talk a bit about that in the coming slides. So down the bottom we have, this isn't real data, this is a schematic to kind of demonstrate the ideas that we're talking about. So question number one, is there a correlation? If there is, we need to understand a little bit more about what might be driving that correlation. The second main question is to ask, well, we need to take into account other things that influence body mass index. And so one of the primary kind of predictors of your body mass index is your age. So there have been studies published which show both in cross-sectional designs but also longitudinal designs that on average there is a tendency to increase their BMI as they get older. And so one of the important questions here is, if we essentially control for age, we pretty much predict that we're going to find a main effect for age. And so the older the participants, the higher their average body mass index. That's a clear kind of prediction. But bearing that in mind, is there an additional effect of delay discounting? So if you saw a bunch of people who are all the same age, is it the case that the people who discount more have higher BMI? So I think that this is, I believe it's simple and straightforward, but not so many of the studies actually look at this. They focus merely on the correlation. I think I'm pretty happy with this other hypothesis that I also kind of came up with, because it's not really the case that if you have high discounting, then all of a sudden you might have a higher body mass index. If you think kind of how this might work in practice, someone who discounts highly could kind of putatively behave in such a way that increases their body mass index over time. And so what we're really saying here is, by asking the question of, does discounting moderate the rate of BMI gain with age, is it the case that people who discount a lot are making a kind of a series of behavioral decisions which lead to them gaining weight faster, and vice versa? Are people who are more future oriented, do they behave in a way where their body mass index grows slowly or not at all? So those are the three main hypotheses that we set out to test. Importantly though, when we measured discounting, we didn't just measure discounting of money. So we did that using the Kirby questionnaire, which I might sometimes refer to as the MCQ, the monetary choice questionnaire. So in this, you have the classic questions. Would you prefer a small amount of money now, or would you prefer a larger amount of money in some future time? And people often go for money because it's just taken as a generic measure of discounting. But we found an interesting idea in the literature as well by Lim and Bruce, and their idea was that if you are really in a hurry to lose weight, this might actually drive counterproductive dieting strategies. And so I'm certainly not a clinician, and my kind of mastery of the kind of clinical literature here is limited, but there is evidence out there to say that the more diets you try, the less effective this is. And so this was really the logic behind Lim and Bruce. Would impulsivity, or rather kind of an urgency to lose weight now rather than more in the future, would that drive counterproductive dieting strategies? They found no significant correlation with their WCQ. So this is the weight loss choice questionnaire. And it was kind of interesting how they interpreted it, because rather than coming to the conclusion that no, there is no correlation, they decided that, well, maybe there should be, maybe we should have detected a correlation, but perhaps they didn't have a large enough sample size. So we thought it would be quite good to measure discounting for both money and for weight loss, so that we can kind of add to this literature to see what happens. So we measured people's age, their height and their weight. That allows us to work out their body mass index. And yet there are papers which describe how men slightly overestimate their height and women slightly underestimate their weight in a self-report setting. But there are other papers which show, depending upon your purpose, self-reported height and weight do a fine job in kind of working out roughly where somebody is on their BMI. So the BMI was our kind of objective scale of someone's kind of weight status, but we also wanted to know what about people's subjective evaluation of their body state. And so we also got people to fill out the Stunkard figure rating scale. Now, the two kind of outcome measures that we looked at, I've just talked about. We looked at the discount rate, which, as I say, are very often referred to as log K, but we're basically measuring discount rates for money and discount rates for weight loss. I think importantly, we only asked people who had expressed an interest in weight loss to complete the WCQ, because there are plenty of people who are at an ideal weight or under their ideal weight. And so if you ask them if they want weight loss now or later, and they don't actually see that as a rewarding thing, then it might be quite difficult to interpret what those scores mean. And so we only proceeded to measure the WCQ in the participants who wanted to lose weight. And we used online survey methods, unpaid, and I think that's relevant here because there is no point for kind of bots, for example, to come along and complete this online survey with random information. Either way, we used quite kind of tight exclusion criteria. If there was a reason to exclude someone, then we basically did. So we went from an initial sample size of 408 down to 381 people who we thought had produced quality data. And of course, another plug, we scored the discounting data into discount rates using the Bayesian methods. So I'm a big fan of plotting your data. I think it's exceedingly important. So I'm going to show you some plots. What we have here is we've got a couple of different graphs. If you focus on the big main panel, what we have is a plot of each participant as a dot, and we can see that the older the participant is, the higher their BMI is on average. And so this replicates basically what you find in large samples. So this is giving us some reassurance that our data is representative. In terms of the distribution of BMI on this right-hand plot, again, what you find in the population as a whole is this positively skewed distribution where you get many people around kind of normal or slightly overweight, and you have this long tail of people who get progressively more overweight. So we've got a good spread of people here that represent the different categories by BMI, and we've got 14 people who we can classify as severely underweight, and these people would be candidates for having anorexia, but we can't say that because that requires a clinical diagnosis. But the point being, we've got people here who are varying all the way across the BMI spectrum. Now, admittedly, if you look at the distribution of ages, it's pretty good in that we've got people, a scattering of people all the way up to 70 odd, but our data is really heavy on the kind of young end of the spectrum, and so that might kind of influence how we interpret this, but I think we've got a reasonable spread. So I'm going to go through a couple of slides now, progressively evaluating each of our 3 core hypotheses. And so the first one was, are the discount rates correlated with body mass index? So firstly, for the MCQ on the left, we found the answer was basically no. And one of the kind of nice things here about doing Bayesian analyses is, rather than just saying, well, we failed to reject the null hypothesis, using Bayes factors, you can actually say the hypothesis of no correlation becomes 8 times more credible after having observed the data. So in my mind, this is much more powerful, and I think that it's an interesting point. If you tend to find some kind of non-significant results, then this is interpreted in a particular way by reviewers and journal editors. But I think that you can make more of your data if you use these kind of Bayesian methods. That's just my opinion. We find a similar finding, basically, that the same absence of a correlation for discounting of weight loss. And so this is kind of a first indication of Lim and Bruce's results, where they didn't find a correlation. Well, we didn't either. I'm not going to look at the Stunkard data after this slide, so this will basically be it. But I won't walk through the Bayes factors, but we essentially find the same thing. We find evidence against the idea of correlations between your discounting and your kind of subjective body status. So not looking good for the correlation hypothesis so far. The second hypothesis was essentially, will we find a main effect of age as we predict, but will there be an additional main effect of discounting? And the way that we approached this was to run a Bayesian linear regression where we put in age, discounting for money, discounting for weight loss, and also the participant sex. And essentially all of the sub-models are run and compared, and so you can say which is the best model. So the best sub-model was essentially one where there is a main effect of age only, and we have kind of similar Bayes factor type results, which basically say, yeah, there's evidence for a main effect of age, and there's evidence against additional main effects of discounting. Now, kind of interestingly, I think that if we had a really large sample, then you also would have found a main effect of sex as well, but we didn't find that in our sample. So if we ask the question, if we take someone of a particular age, is it the case that the higher discounters have higher BMI and the lower discounters have lower BMI? The answer seems to be no. So that's not looking very good for the second hypothesis. The third hypothesis is a little bit more complicated to go through. We basically ran some kind of Bayesian moderation analyses, and for the discounting of weight loss, we essentially find no difference in the slope of how BMI increases with age. So what we have here is essentially two lines plotted over the top of each other, representing people who discount the most versus people who discount the least. And we can see, because these lines are over the top of each other, this is the most lack of evidence that I've ever seen for this kind of moderation hypothesis. Going to skip forward a bit though and focus on the slides of discounting for money. Does this moderate the rate of BMI gain with age? So we've got the same curves plotted. We've obviously got different data because we're looking at different discount rates. And here what we can see is that the people who discount the most look like at any given age they do actually have higher BMI than people who discount the least. Although I'd say it's not quite so clear. I'm actually going to, in the interest of time, I'm going to skip over some of the nuances and just read out a quote which I think conveys the point quite well. The lowest discounters gain about 2 BMI units per decade, whereas the highest discounters gain about 3 BMI units per decade. While this is interesting, the practical consequence of this is negligible. If we make some reasonable assumptions, this means that people with the highest discount rate will gain only 0.35 kilograms per decade more, that should say, than a person with the lowest discount rate. And so according to our data, over a 10-year period of time, someone who discounts the highest will gain the physical weight of approximately 9 donuts more than someone with the lowest discount rate. So we argued that this is effectively no effect. If you are convinced by that, then that's great. If not, you can ask me in the questions. So a quick summary, how are we doing with our hypotheses? I've represented them here in visual form, and really quickly, I'm going to show you how we're doing. No, 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 no. So I think that's fairly clear. We didn't find any evidence that discounting was related to body mass index using any of our measures. So what we have is a bit of a weird situation, because we have multiple meta-analyses in the literature which kind of report that there should be some kind of correlation, some kind of small correlation between discounting and body mass index. But we didn't find this. One of the very important points, though, about the meta-analyses is that they all find considerable variation between the studies. So some studies will report no relationship or maybe even negative, but on average, they find a small positive correlation. And so what are you supposed to do in this situation? What we did was I created a Bayesian meta-analysis, partly because I wanted to learn how this was done, so I coded it myself. If I was doing this again, I would probably use JASP, but when I did this, the feature didn't exist. So we based our meta-analysis on a previous one, but we added some studies. We ran this through some code that I wrote, and it's actually pretty interesting. This is probably not a good way to write papers quickly, but it is a good way to understand exactly what's going on. And Bayesian meta-analyses sounds like difficult times difficult, but it's actually really easy once you know a few basics. But in order to kind of explain our results a bit more, I'm just going to briefly go over the idea of fixed effects versus random effects. So if you were to do a fixed effects meta-analysis, what you're basically saying is that all of these studies are reporting effect sizes, in our case, correlation coefficients, which are all samples from a core kind of underlying population value, a true value. And they might be drawn from this distribution with variation depending upon the sample size. Now, if you do a random effects meta-analysis in our example, what we're saying is that each of these studies is not actually measuring the same underlying effect size. Instead, there might be additional study level variation, and we don't necessarily know where that variation is coming from. But what we can do is we can ask the question, is there additional study level variation that we can then go on and investigate further? So if people have questions about that later on, then that's fine. What we got out was this kind of classic forest plot. And so we can see that some studies, there's one study that reports a negative correlation coefficient, some around 0, but then we can see many of them report a small positive effect size. And if we look at this graph below, what we can see with the dashed line, this represents our Bayesian prior beliefs over correlation coefficients. And so we chose this kind of nearly uniform shape here, but which represents the fact that we're a bit more likely to observe correlation coefficients of 0, and we're kind of unlikely to see correlation coefficients of exactly 0 or -1 or 1. After we observe the data, though, from the studies in the meta-analysis, we can refine our Bayesian prior to come up with our Bayesian posterior, and that's shown by the solid black line. And what we find is that we actually have good kind of credible evidence that there is actually a small positive effect size centered on an R of 0.15. If we were to ask the question, what's the kind of Bayes factor of there being no correlation, we can actually say that our belief in no correlation has gone down 21 times after having observed the data as compared to our prior beliefs. And so this is interesting. Our study is saying no correlation. The meta-analysis that we did is mirroring the other meta-analyses saying that there is a correlation. However, if we ask the question about fixed versus random effects, what we actually find is that there's essentially infinite evidence here for some degree of study variation. And so putting that into plain English, it basically means that we can be very sure that all of these studies are not reporting the same underlying correlation coefficients. The reason for that could be varied. We'll go into that a little bit more in a few slides, but it could be the methods that people use, it could be the participants within each study, and so on. Right, so I'm going to attempt to wrap up now. So is there a BMI discounting relationship? So on the yes side of the camp, we have 4 meta-analyses, which all suggest a small but positive correlation, which is not so good. Maybe you'd like to see a high correlation. Then again, if there are many different factors which influence BMI, it's potentially quite kind of good and interesting that you can actually get any correlation at all just from a discounting measure. So you can interpret that in different ways. On the no side, we have our kind of, I would say from the studies in the meta-analyses, ours is kind of medium to large in terms of participant size. Now, not to demerit anyone else's individual study, but I don't know what other people did in their studies, and I do know what I did in my study. And so my kind of subjective faith in the data is kind of high, and other people might not have the same level of faith, for example. But if I'm being a Bayesian and analyzing the data that we got, then we clearly have to say there is no evidence here, just considering our data. But if we look at kind of all the data in the round, we basically see overall, well, maybe there is a positive correlation here. But I think the issue of study variation in meta-analyses doesn't get enough attention. And so if what you're trying to do in a meta-analysis is to work out what the overall correlation is, what the overall effect size is, and you're doing that by essentially fancy averaging over lots of studies, then you kind of have to ask, well, are these studies actually doing the same thing? Are they measuring the same, are they measuring discounting in the same way? Are the participant pools kind of similar to each other? Do some focus upon students whilst others focus upon clinical populations? And so we've got these big question marks here. As time goes on, I'm less confident about sitting on the no end of the spectrum. I am actually relatively convinced that there is something going on here, but we have this between study variation, which at the moment is not yet explained. And so that is the focus of the current work, where we're looking at these issues of the methods, the participant composition, and we've also got some kind of preliminary data where we've also looked at discounting of food rewards. So I think that pretty much wraps up for me. And if you want to tweet angry things or positive things at me, then I'm at Inference Lab. So I'll hand over to someone, Darren or Craig.
Yeah, thanks, Ben. That was really interesting. I'm just trying to get your camera to go live for the Q&A. It doesn't seem to be working. I'm not sure if there's an issue with the connection, but if not, then your slides and your in fact, if I just
Great. I've stopped sharing my slides.
Okay, maybe that will work. No, it doesn't look like it will. So it's just me on the screen, which is great, I'm sure, for everyone who is watching. Right, so we do have some questions. Thanks very much. That was a really interesting talk and a really nice kind of exploration of how you get from one kind of research question through a series of studies, a series of findings, to actually end up being maybe a little bit unsure about what your final conclusions are. I think that's really refreshing to see. What I will do is I'll just read out a few of the questions that we've got coming through. And I think actually I can probably send you live now. Yeah, so you're on the screen. Okay, so the first question that we've got is, do the average discount rates for money outcomes ever actually match the real or nominal interest rates for the period?
Right, so I would put money on the fact that this question maybe came from an economist, and if so, that's totally fine. So in order to answer that question, I should really kind of explain it a bit. So one form of discounting that people have thought about is exponential discounting, and this model kind of comes from the economic side of the literature. The idea being that if I forego some money now, well, if I had some money now and I put that in the bank to earn money, to earn interest, how much money would I get in the future. And so what you might do is you might compare that future money that you have saved or invested with the amount of money that is offered in the future. So what we find is, even though that might be a very sensible way of doing things, it might be a very sensible way of maximizing the amount of money that you have in a saving situation. The literature kind of shows that if you look at how people actually do behave, they don't really behave in this kind of exponential discounting type manner. Instead, the discounting can be described in a much more hyperbolic fashion. And so in this talk, I didn't go into the different types of curves or the different models that explain the behavior in detail. But in short, I would say that people don't look like they discount exponentially, but as to whether they are sensitive to things like interest rates or investment returns, I'm not 100% sure. That's a bit more on the kind of economic side of the literature for me.
Okay, thanks very much. We've got another question about, so it's more of a kind of method-y type question in terms of the exclusion criteria that you used. So you said that you reduced from kind of your main sample down to an analysis sample. What were the exclusion criteria that you used for that?
Oh, okay. So it's difficult for me to remember exactly. I think what we did was, because this was a number of years ago, and it was one of the first attempts to do online survey methods, we didn't necessarily include any kind of catch questions like mini Turing tests. So what our exclusion criteria were based on was essentially how kind of meaningful or sensible were the values provided. So if they said that their age was 5 or 500, then this obviously didn't make any sense. We excluded them. We also, when we're asking for people's heights and weights, we also ask them to provide that in the units that they prefer. Now, sometimes they don't actually provide the units, whether their weight is in kilograms or pounds. And so we went through a process of working out, is this a clear answer? Oh, well, it must be kilograms. If it was unclear, or in fact that the number was an extreme outlier, we would just exclude it. So we did a similar exclusion criteria based upon the discounting scores. So if the behavior, if their discounting behavior couldn't be explained very well by a hyperbolic discounting model, then I believe that we binned those participants as well.
Okay, thanks very much. We've had a couple of questions and a comment about the question about the BMI index itself. One question was asking about your opinion about health professionals who believe that the BMI index is inaccurate. Did you have any thoughts about that?
I mean, I've got kind of layperson thoughts. I'm not an expert on kind of anthropometrics, but yeah, I mean, I think the criticisms are well known. I think when you look at the equation, it essentially treats people as a two-dimensional square. And so that's slightly inaccurate. It's also going to not distinguish between people who might have a high BMI because they go down the gym every day versus those who don't go down the gym every day. So for sure, it is not the best measure. And I think basically the vast majority of people who record BMI and publish using the BMI measure all know that it is not necessarily the most accurate. But yeah, we looked into a number of papers evaluating the accuracy of self-report, and it seems like it's okay to give you a ballpark measure for sure.
Okay, I think that kind of speaks to one of the other comments that was about the BMI, saying that it's less less that it's invalid and more maybe that it's just a little bit noisy than anything else. There was one final question that we've had come in saying that they were wondering about whether discounting is affected by expectations or priors about different types of good or bad reward. Items influence you much more now. So for example, is it different if you're expecting, and the question gives the example of a nice toffee crisp now, or some gruel in 36 days time?
Yeah. So people call this the domain effect. So you can run this type of experiment, both with things that are clearly considered as gains, or you can run it with things that are considered as losses or punishments. And in the vast bulk of the literature in the game domain basically sees that people discount to some degree, more or less. But when you start looking at discounting of losses, you actually get much more varied behavior. So on average, people will actually discount losses more. And I think, I won't go off on a mini literature review, but people have certainly spent a lot of time and effort looking at gains versus losses.
Okay, thanks very much. I think that is all of the questions that we've had come through. So clearly a very kind of comprehensive and really interesting talk. So thank you very much for that. Okay.
Thanks very much.
Thank you. So thanks to everyone who's still with us. Thanks for kind of sticking with us for the full hour. We do have a series of other seminars planned for both this term and the term after Christmas. So events will be announced kind of as the details are confirmed. So do keep an eye on the NTU Psychology Twitter and Instagram feeds. And if you're kind of within NTU, to keep an eye on the community pages on Teams as well. But that's everything for today. Thanks very much for joining us, and we'll see you again next time.